Namaste all. Welcome to VCube Smart Learning. The exams are around the corner, the 10th CBSE exams. And as a teacher, I would like to wish all students the very best of luck. I'm sure your preparations are in full swing. And you can visit my channel. I have given the link below to get a few tips about how to approach writing exams, especially maths. As a maths teacher, this 10th grade is a turning point to many students. And I would like to give a few guidelines about one particular chapter which students really find it difficult to analyze. And that is Introduction to Trigonometry. This is the class where trigonometry is introduced to the 10th standard CBSE students, and the ninth get introduced, the ICSE students get introduced in the ninth grade. So it will be good guidelines for the ninth grade students also. I'll be giving a few guidelines about how to approach problems, because trigonometry is a subject which will be carried on to your 11th in case you're taking a science, and that is a stepping stone for calculus. And I find students struggling to find the starting point to solve the problem. They don't know from where to start, how to start. And each problem in trigonometry is different. It's not like the other chapters where you have some methodology. So these guidelines, I'm sure, is going to help those students who find trigonometry difficult, and also who students who do trigonometry very easily. These guidelines are going to really help. I'm going to give you a list of things that you have to look out for when you get a trigonometry problem, so that you'll have some idea about how to solve them. But before that, a short video about the feedback from my students who have taken my classes. I take maths classes from 9th to 12th grade, CBSE, and I do workshops for students of 8th and 9th in select chapters, thereby making their foundation and conceptual understanding strong. And when they come to 9th, they are confident enough to do the problems. And I also take IIT foundation classes for 8th and 9th. But before we get started, a short video about the feedback. Here we go.
Hello Vasudha ma'am. Thank you so much for being there in Vajra's life when she most needed you. Your technical way of teaching and your methodology has improved Vajra's mathematical skills so much that she was a kind of person who hated maths till she was in 9th standard, and all of a sudden overnight she fell in love with the subject, and you are the main cause for it. All the credit goes to you. Thank you so much and all the best to you.
Hello Vasudha ma'am, thank you so much for being a teacher for me and boosting my confidence in mathematics. You were not only a great teacher but also a best friend to me. You were just an SMS away from me when I really needed you. That also boosted my confidence. And I'm pretty sure that with a teacher like you, I'll be nailing my exam with flying colors. And thank you so much once again.
Namaste, my name is Toral Vashi and this is my daughter Harshi. Harshi is taking tuition from Vasudha ma'am from past 2 years, standard 9 and 10. Vasudha ma'am is really good teacher. My daughter's grasp and understanding of math has really improved in past 2 years. Miss Vasudha also takes regular test at the end of the unit, which helps my daughter in analyze the subject and clarity of the concept.
Vasudha ma'am is not just a teacher but also a mentor to me. She's ready to clear any doubts if I have, and she's always there.
Thank you.
Hi, my name is Smriti.
Hi, I'm Pratibha.
And I'm currently studying in 10th grade and I joined Meetri Smart Learning last year. Vasudha ma'am helps us understand each and every concept very clearly, and we also solve plenty of important questions in these classes. All the content which is missed out in the school is being covered here. Ma'am also organizes weekly assessments which help us analyze and work on our mistakes. After going through the chapters once, revision classes were also being held where we solved multiple sample question papers, which gave us confidence and also a way to manage time efficiently.
Overall, V3 Smart Learning has been very helpful for my daughter, and as a parent, I can be rest assured that my daughter is in good hands. Thank you.
Hello everyone, I'm Ariman. I'm in 12th standard and I'm learning maths from Vasudha ma'am. She's a very good teacher and she taught me all the concepts very well. I got a better understanding of the problems and the solutions thanks to Vasudha ma'am. She also taught me a lot of tricks that made it easier for me to understand and do the problems. I would recommend Vasudha ma'am for maths tuitions. Thank you for being my teacher, ma'am.
Welcome back. So, the first thing in trigonometry is you'll have to learn all the basic ratios. What is sine theta, cos theta, tan theta, secant, cosecant, and cot theta. So the basic ratios you'll have to know. The angles, that is sine 30, sine 45, sine 90, and so on. You will have to be thorough with algebraic identities. It's very, very important. I find students always fumbling with algebraic identities, which you learn in your 8th grade. That is a squared minus b squared, a plus b whole squared, a minus b whole squared, a plus b plus c the whole squared, a cube minus b cube, very widely used. So you'll have to be thorough with all the algebraic identities. So please make a small formula book where you have all these handy and every day keep going through them. So these applications are used in trigonometry. Now, when you get a trigonometry problem, the first thing that we have to do is have a track on your right hand side. What does your right hand side look like? Suppose if your left hand side is having a tan and a cot, and your right hand side is having sine and cos, then obviously you will have to convert the tan and cot into sine and cos. So when you solve a trigonometry problem, it's very important that you keep track of what your RHS is. For example, because one trigonometry problem can have multiple solutions. Now, suppose if I have sine square theta minus cos square theta, this is the problem. Okay, now this can have multiple solutions. It can have, say, 1 minus 2 cos square theta as a solution, or 2 sine square theta minus 1 as a solution, right? So looking at the right hand side, you will have to start doing the problem on the left hand side, keeping track of the right hand side. Okay, so suppose if you want this, then you'll have to convert this sine into cos. Suppose if you want this, the right hand side is this, then you'll have to convert cos into sine. So it's very important to keep track of what is required in your right hand side. That is the first tip. Second, now suppose the first, after you look into whether the right hand side is tan, cot, and sine, cos, whatever I have told, make use of trigonometric identities as much as possible. So you have 3 trigonometric identities which you have to remember. That is sine square theta plus cos square theta is 1. 1 plus tan square theta is secant square theta, and 1 plus cot square theta is cosecant square theta. Now you will have to know all these 3 in any form. Suppose you have a problem where you have secant square theta minus tan square theta. You should be able to write 1 instantly. You should not think. So instead of knowing only these 3 in a straightforward way, learn all the variations of these 3 identities. So when you get a problem, first see if you can apply an identity. That is the first step. For example, 1 plus, I'm taking a problem, tan square theta by 1 plus secant theta. You have to prove this is equal to secant theta. So this is a very simple problem. So what I'm doing is, one way is you take LCM as 1 plus secant theta, you convert tan into sine and cos, you convert secant as 1 by cos. Anyhow you do, you will have to get the solution, you will get the solution. There's no doubt about it. But there's a difference between eating like this and eating like this, isn't it? So what you do, The first thing is try to always use trigonometric identities wherever possible. For example, this tan square theta, I know it is secant square theta minus 1 by 1 plus secant theta. Correct? So I'm taking the LHS. I know tan square theta is secant square theta minus 1 and I have a secant theta in the denominator. So this, now what I can do, I have applied the trigonometric identity. How do I get rid of 1 plus secant theta? Why? Because in the right hand side, the denominator is 1. Right? On the left hand side, you have a denominator of 1 plus secant theta, which means 1 plus secant theta should get cancelled. So this is how your thought process should be when you practice problems. In the exam, you cannot think like this, but when you practice, your thought process should be like this. The more you practice, that thought process gets impinged in your brain and seamlessly you'll start solving problems. Now, once you've applied the trigonometric identity, next, you look for algebraic identity. Do you have any algebraic identity which I can use? So you see that this secant square theta minus 1, I can write it as, this is in the form of a plus b into a minus b. That's why I said you have to be thorough with your algebraic identities. So this and this gets cancelled. So you get 1 plus secant theta minus 1, 1 goes, you get secant theta, which is the RHS. See, just 2 steps, you will get the solution. So always use trigonometric identity first. See if you can use any trigonometric identity. How do I know whether I should, whether there is any trigonometric identity? See if you have a sine squared, tan squared, secant squared, cot squared, any square you see where you can apply the trigonometric identity. Then you try to apply the trigonometric identity. Next, what you do, you try to use algebraic identities. Now here we have used both trigonometric identities and algebraic identities. So in every step, try to think in these terms. Can I use any trigonometric identity? Can I use any algebraic identity? Now some problems you will not be able to directly apply trigonometric identity. So the next step is look for algebraic identity. For example, I have secant power 4 theta minus tan power 4 theta. Prove that it is equal to secant square theta plus tan square theta. Oh, sorry. Prove that it is equal to 1 plus 2 tan square theta. Okay. So now here what you can do, you don't know secant power 4 theta. There is no direct identity for it. You don't have a direct identity for tan power 4 theta. One way is you write secant theta as 1 plus tan, you write this as secant square theta the whole square minus tan square theta the whole square. Sorry, my writing is pretty bad, I think. Okay, now you have this. The next step, now you have a secant square theta where you can apply 1 plus tan square theta the whole square. Now, you will get this also. This also you can do where you have tan square theta the whole square. So you expand this as a plus b whole square and then you cancel out this tan power 4 theta with whatever tan power 4 theta you get here and you'll get 1 plus 2 tan square theta. The other way is, you see this is a squared minus b squared, which is nothing but secant square theta plus tan square theta into secant square theta minus tan square theta. So this is 1. Now what is your right hand? This is also an answer. This also is a correct answer. But that is not what your right hand side is telling. So that's why I say always keep track of what your RHS is. You don't want a secant square theta in your right hand side. So eliminate that. You know how secant square theta is related to tan square theta. So you say 1 plus tan square theta plus tan square theta. So you get 1 plus 2 tan square theta. So a trigonometric problem can have multiple solutions, but you have to align your solution according to what the problem states. As I said, Your answers may not be wrong, but they are not the ones which the examiner is looking for. So you have to bring it to that, do some manipulation so that you express it in the way that the examiner wants. Sometimes you will have sine power 6 theta minus cos power 6 theta. Okay, now you don't have algebraic identity for power 6, but what you can do, you can write sine square theta whole cube minus cos square theta whole cube. So this is a cube minus b cube. So as I said, first look for trigonometric identities, then look for algebraic identities. A cube minus b cube is a minus b into a square plus ab plus b squared. You have to be very thorough with all your algebraic identities. They play a huge role in trigonometry and calculus. That's one point. The next point, whenever you have square roots, for example, you have 1 plus sine theta by 1 minus sine theta. So how do you solve this? It's a very straightforward thing. You have learned rationalization in your 9th grade. Just rationalize the denominator and proceed. That's one thing. But there are some problems where you have, see, your idea of rationalizing should be your numerator should come to a perfect square. Your denominator should come to a difference of squares. That means your numerator should come to, suppose if this is the problem here. These are not irrational numbers. They don't have a square root, isn't it? But how do you do such problem? These problems can be a little challenging. So what you do is you multiply and divide by the conjugate of this, what we call conjugate, that is 1 plus cos theta plus sine theta by 1 plus cos theta plus sine theta. So now you see these two terms are same. So my numerator, I'm reducing it to a plus b plus c whole square. This is the perfect square I'm reducing it to. The denominator, you'll have to reduce it to 1 plus cos theta the whole square minus sine square theta. This is a square minus b square. Then you expand this as a plus b whole square, and then you manipulate. Manipulate means you do a proper, go step by step, reduce it, simplify it, and then try to get the RHS. As I said, RHS, you should keep track of what the examiner wants. So the next is you look for any rationalization, or you look for multiplying the denominator and numerator in a way that your numerator comes to a plus b whole square or a minus b whole square, and your denominator comes to a squared minus b squared. Now, these are some of the tips that I wanted to bring out. So the key is keep a track of your right hand side. So as I said, if the right hand side has tan, cot, and the left hand side has tan, cot, and the right hand side has sine and cos, then you'll have to convert your left hand side. Now, the worst case, you really don't have any idea about how to do the problem. Your identities, you're not able to apply, you're not able to apply the algebraic, you don't know if you can apply the algebraic identities. The problem seems big. No problem is big. Trigonometry, if you apply this guideline that I've told you, you can get the most of the problems you can get it in 3 or 4 steps. They're very simple, but you have to apply the right concept at the right time. So you have suppose you don't have any idea, you don't know whether you should rationalize, you're totally blank. The best thing to do is, so that you don't lose the whole marks, take the right hand side, simplify it, get an answer. Take the left hand side, simplify it, get the same answer, and then do hence LHS is equal to RHS. Now don't take this as a thumb rule and do it for every problem and then say I saw it in some video and they asked me to do this. No, your first approach should be start with the LHS and arrive at the RHS. In some cases, you can start with the RHS and arrive at the LHS. And this method of solving LHS and getting one answer and solving the RHS separately and getting one answer and showing both are equal should be the last resort. Only in case that you're totally clueless about how to solve the problem. So I hope that this will definitely help students, start practicing, and trigonometry, work out at least 10 problems every day. Whatever subject, other subject you're doing, even if you're doing maths, you do some other, you do a chapter of maths and 10 problems of trigonometry, because it is not straightforward and it carries on to your 11th, which is a basis for calculus. So again, wishing all students the very best of luck. I have put down my phone number. If you want to register yourself for any workshops for the lower classes, or for the IIT foundation classes, or for the regular 9th to 12th classes, you can contact me. All the very best. Thank you. Namaste.